Okay, physics students, I'd like to do a little review with you for your Chapter 3 quiz, which will finish your Unit 1. So I'll be giving that to your teacher. So at the end of this, I'll talk to you a little bit about what you need to review. So let's do the practice problems. We'll actually start with the one on page 1 in the middle that says page 67. A race car's forward velocity increases from 4 meters per second to 36 meters per second over a 4-second time interval. What is the average acceleration? So let's look at the formula, which is average acceleration is change in velocity over change in time. So remember that before you even touch your calculator, the first thing you need to do is to list all of your variables that we know. So if we unpacked this, we know we need to know VF minus VI over TF minus TI. So on the side of your paper, VF equals VI equals TF equals TI equals. So our final velocity is 36 meters per second. Our initial velocity in this case is going to be 4 meters per second. Our final time is going to be 4 seconds. And our initial is going to be 0 seconds. So the next thing then that we're going to do is we're going to plug those numbers into our equation. Still not touching our calculator yet. Make sure you show all your work. Okay, so plugging into our equation, we have velocity final, meters per second, minus velocity initial, 4 meters per second, divided by 4 seconds minus 0 seconds. And we end up with 32 ms, meters per second, over 4 gives us 8. And we've got 8 meters per second squared. Remember that acceleration, the units are meters per second squared. Maybe you can see how to do that. Do it longhand and you'll see those. Okay, there's definitely going to be one very similar, very similar to this. It actually has even less steps though. So that will be good. Okay, next up. So the next problem is going to be the one right below it about Brianna driving a race car. And so Brianna's race car is 52.4 kilometers per second squared. That is the acceleration. So we know acceleration. We want to know how far from the starting line is will she be. So that's going to be position final. So you're going to see the equation there. Going to look like this. Xi plus VI TF plus 1/2 A times TF squared. Now, often, let me show you in a color here. These two are probably going to cancel out because Xi is usually going to be 0. VI is usually going to be 0. So that becomes 0 plus 0 times whatever this is that no longer exists. So if all of these numbers are confusing to you, just remember they might actually be canceling out. Let's list our variables. So we have xi is 0, vi is 0, tf is 3 seconds, that's an S for seconds, and A, acceleration, is 52.4 kilometers per second squared. Okay, so let's do some math. So remember how I said that the first two things are pretty much going to cancel out. So that leaves us with 1/2 times 52.4 kilometers per second squared. And we've got, I'm putting 9 seconds squared. Why did I put a 9 when the time was 3? The reason is because if you look back to the equation, you'll see that time final is a number that is squared. Our time was 3 seconds. When we make that a square, 3 times 3 is 9 seconds squared. That's why I did that. Now it's okay to touch your calculators, but let me just show you how the units are going to cancel. You can see that seconds squared will cancel as we multiply here. Now on your calculator you can just straight up for 1/2 you can put in 0.5. 0.5 times 52.4. Then no need to push equals, or you can equals, and then times 9, and we end up with final position equaling 235.8, don't forget the units, kilometers. Okay, I'm going to do the other page on a second video because I just want to make sure this video works before I keep going. Okay, bye.